From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Yeah, so that's one of the key challenges that we face. We're capturing gigabytes of 3D data per minute, and close to a gigabyte of data per layer. So that's one of the key technical challenges that we face as a company. We have a great team of people, PhD in graphics and computer science that have been able to crack this problem of real-time scanning, processing in a matter of hundreds of milliseconds, because you're capturing a scan, then you're comparing to your CAD model, and you need to print your next layer within a few seconds. So all of this processing has to happen in essentially real time. So we leverage GPU technology, high-speed computing, and a lot of this is happening in real time.
That was Javier Ramos. Javier is a co-founder and the director of hardware at Inkbit. He leads system and technology development activities and previously worked at Rethink Robotics and Leaf. Inkbit was spun out of the Computer Science and Artificial Intelligence Laboratory, or CSAIL, at MIT in 2017. They have built the first 3D printer driven by vision-based feedback control, and earlier this year announced their first machine called the Vista. He joins the show today to talk about the journey to commercialize the Vista and how AI and vision systems can be used to improve the end-to-end 3D printing process. Javier, welcome to the show. For the audience at home and wherever they may be listening, why don't you tell us a little bit about yourself and how you landed in the additive manufacturing industry?
That sounds good. Happy to talk about my background, Mike. Thank you for having me in your show. So just a little bit of background on myself. I'm a co-founder of Inkbit. We are a 3D printing company based in Boston, Massachusetts. And the way I stumbled up on additive manufacturing, I was an undergrad at MIT in mechanical engineering, and later a grad student. And as part of my grad school work, I worked with a professor called Wojciech Matusik, who's actually one of my co-founders at Inkbit as well. And we started, as part of my thesis project, we explored combining inkjet 3D printing, which you might be familiar with, the Object Connects technologies. So combining inkjet 3D printing with machine vision. And this goes a little bit into what the core of the technology will be, which we'll talk about later. But that project evolved throughout the years at MIT into what became Inkbit. So in 2017, we spun out the company. And since then, I've been working on the technology and product side of Inkbit.
So what was it like being at kind of MIT and going through the process of spinning out a company? I mean, I graduated in 2008 from MIT as well, course 3, and had there wasn't really that many 3D printing kind of pockets around the campus, but now like everywhere you look and there's kind of new companies and really exciting research going on. So kind of tell us a little bit about kind of what that process was like of taking a technology from research and ideas and bringing it out of the university into a real company.
Yeah. So I would say that 3D printing had two spikes, one in the 90s and one in the 2010s. And actually a lot of the early technology, especially binder jet technology that we recognize from Z-Corp, it started off at MIT in the 90s. And then there was a period of, I guess, quiet development in the industry. And then in the 2010s, there was suddenly an explosion of interest and hype. So around 2014 or so, where we were working at MIT, there was a lot of new companies like Formlabs were spinning out. So it was really exciting time around 3D printing, and a lot of efforts, especially at MIT on the research side, coalesced around that time. So a lot of young faculty getting into the field. So there's professors all around electrical engineering, mechanical engineering, chemistry now doing 3D printing work. So it was a very exciting time And obviously MIT has a whole ecosystem of companies and resources, and that's actually in that ecosystem that we met our third co-founder, Davide Marini, who's our CEO. So he had started another company out of MIT, and we later met him through the same ecosystem. And then we kind of pulled together our efforts and spun out Inkbit in 2017. But MIT is a magical place, a lot of technology, a lot of passionate people really trying to do the heavy lifting of taking a technology from the lab, from an academic environment into industry. So it's exciting, definitely.
And so much research kind of gets buried. It's read once by the thesis advisor and the person who wrote it. Kind of what was the moment like when you knew that you had kind of an idea that was commercializable and kind of had some traction?
Yeah, so we, early on in the life of the company, we're always curious about the commercial potential of sort of this approach of machine vision and inkjet. So we started engaging early on with industry partners or customers. And actually, kind of the key relationship, I'd say, that led to the birth of the company was a project we had with Johnson & Johnson, and we were exploring specific things that they wanted to do with 3D printing. And that's really what led to the genesis of Inkbit on the commercial side. And the technology, the company, the approach has evolved over the past 3 years. But I'd say that was sort of the little bit of push that led us to that catalyzed the birth of the company. We also early on applied to an SBIR, which some of you might be familiar with. It's a grant program from the government, and there's different agencies that granted. We received an award from DARPA. And that was also another piece that helped catalyze the company early on. So we didn't actually raise funding from outside investors until 6 months into the company. So the first half year of the life of the company was funded by customer projects and this SBIR from DARPA.
So when you talk about machine vision and kind of some of the underlying technology within your platform, can you give the audience kind of like what's the 101 on kind of machine vision? What do they have to know? What's it all about? Kind of, I know enough to be dangerous, but that's about it.
So yeah, this question leads to really the core of Inkbit and what we do. So for those of you who are familiar with the Connects technology from Object Stratasys, the way this inkjet 3D printers work is you have inkjet printheads that essentially are shooting out little droplets of material onto a substrate. And then the way this Connects machines work, they have a little roller that planarizes every layer. So similar to an SLS machine where you have a recoder or a planarizer, with this inkjet technologies, you put down a layer of material. This is a photopolymer technology, so a UV resin. And you have this rotating roller that literally touches and planarizes each layer. And then you have a UV light that fixes or polymerizes the material. What we found early on is that this roller mechanism that's planarizing and squishing and making every layer flat has a series of drawbacks. So the first one is that you're physically contacting the material, so it limits the kinds of materials that you can use. Second, about 30% of all the material you deposit actually gets picked up by that roller. So you're wasting about 30% of all the resin you put down. And the third one is that you lose accuracy and precision. You're smearing the materials as you put them down on every layer. So what we do is we get rid of that mechanical roller, that mechanical solution, and we replace that with a very high speed 3D scanner, and that's really the core of our technology. This high resolution, high speed 3D scanner that essentially enables us to scan every single layer after it's printed. So as you're building out the parts, you're gathering this high resolution 3D maps of the surface of the part. And we use that data to then generate the print data for the next layer. So we're actively and adaptively generating the print data on the fly. So we're doing closed loop feedback correction based on the 3D scan data. And that has a number of benefits. The first one is it opens up the types of chemistries that you can print with this technology. So all the printers today, from SLA, inkjet 3D printing, they use acrylate resin. So this is dominant chemistry across all UV resins. So, and the reason for that is when you shine UV light onto this acrylate resins, only the selective area that's exposed to the light will polymerize. Some of the resins we're using are called dark cure or continuously cure. So it means if you shine light onto the material, let's say you have a pool of resin, the reaction will react the whole bat eventually. So if you have a roller or something that's touching the material, you have a continuous cure chemistry, material will get stuck on the roller and will jam it. So that opens up new chemistries that we can print. For example, epoxy chemistries we're printing with our system. So we're now breaking away from that acrylate chemistry, which is the standard across the industry. And the second big benefit is the fact that you're capturing data of the whole process. So you are you have a fully traceable process that you can go back and inspect the part in the post process.
And so with the camera system, are you able to measure / view kind of the degree of cure? Is that how it's like, is there kind of a change at the borders of something that's cured and then the rest of the vat that you're able to pick up in each layer? Is that kind of what?
Yeah, when we deposit material, we always ensure that our chemistry is reactive enough so it would react right there in that layer. So
okay,
we do for some chemistries that are slower cure, like some of the high performance epoxy materials that we're printing might be cured, let's say 80%, and they might continue to cure over the print. And if there's any change in geometry or anything like that, we detect that and we're just printing the correct geometry in the subsequent layers. So, yeah.
So it's kind of calibrating as you go. You start kind of first layers based on the CAD model. After that, it's kind of the CAD model as a guide plus whatever is reacting in the system. If you see a little drift to one edge or the other, like that's being corrected as it goes up.
Exactly. It's actively comparing to the input CAD model, and it's trying to deposit material in a way that's as close to that input CAD model as possible.
That's great. And one of the challenges that we've seen in some of the powder-based technologies as people put kind of camera systems into kind of even just take a basic picture or a thermal map of every layer is like, it's all layer technology. So you get a 4-inch part and you have a terabyte of data that you have to do. So how do you kind of manage that information to get all that real-time feedback and put it back into the printer as you're doing it? So
that's one of the key challenges that we face. We're capturing gigabytes of 3D data per minute, and close to a gigabyte of data per layer. So that's one of the key technical challenges that we face as a company. And we have a great team of people, PhD in graphics and computer science that have been able to crack this problem of real-time scanning, processing in a matter of hundreds of milliseconds, because you're capturing a scan, then you're comparing to your CAD model, and you need to print your next layer within a few seconds. So all of this processing has to happen in essentially real time. So we leverage GPU technology, high-speed computing, and a lot of this is happening in real time. So, and on the post-process, you accumulate all this data over the print, and then you might want to visualize it for inspection or verification. So this is all also a lot of data that needs to get stored and compressed. So we're also working on techniques to make all of this more efficient in terms of the storage and processing of that data.
And so many of the printers on the market now kind of put these sort of, may call them in situ monitoring or cameras or whatever they be, some other sensors into their printers kind of as an afterthought, right? Like after a few years they developed kind of the printer, let's make something like reasonable and stand up and repeatable. Kind of when you guys started knowing that kind of the foundational layer of what you're doing is kind of this machine vision kind of constant monitoring process, were there any kind of different approaches you took with how you design your machine or how you thought about kind of the user interface or how it's can actually perform when you're building it?
Yeah, and this is a great point, because we indeed designed the machine from the ground up to be this vision-based process and piece of hardware. And the goal is always to make it as magical and back-end as possible. We didn't want the user to have to, we want everything to happen in the background automatically, efficiently, seamlessly. And I know that a lot of these other solutions that you see out there are kind of, like you said, pieces that get put in, complicated and just cobbled in. But we design everything, the software, the UIs, everything to be, this vision, machine vision foundation, like you said.
Does it give the designers any different rules or feedback? Are they able to do different things with knowing they have some kind of machine backup that, like, if they really mess up, you're kind of the machine may hopefully fix it a little bit with, I don't know, supports or anything like that with what you guys are doing?
Yeah, I'd say that the main unlocking for designers is this new materials that we can print. Sure. Because of the contactless nature of our process, we can print these new chemistries that unlock a few applications. So just to give you an example, we have this very chemically resistant epoxy material that can survive in acetone, alcohols. So that not only allows designers to design things like manifolds that would go on an industrial machine that's handling aggressive fluids. In terms of the in-process benefits, when you're printing a lot of this features, for example, thin walls or small channels that tend to be problematic during printing, the vision system can correct and can identify any issues in these areas, and in real time, it's correcting and trying to achieve that geometry that the designer specified. So we're trying to be as faithful as we can to whatever the designer designed in the process.
Do you see core industries or applications for the technology that you're really working towards and optimizing? So
we have three, I would say, market verticals that we're targeting. There's some medical applications, and we have, for example, a really nice soft elastomer. That's kind of a very nice substitute for all this, what we traditionally be like silicone parts. So we're working a few customers printing parts that we traditionally made with silicone. We're targeting an industrial applications. There's a few, and I just mentioned one, for example, the fluidic manifolds, where you want to print fluidic components, hardware manifolds that see aggressive media. We have, one thing I haven't mentioned is that since we're using inkjet as a deposition technology, we can print multi-material parts. So one area of interest is robotics. So there's a lot of end-of-arm tooling and effectors that right now might be like CNC machined or even 3D printing, but it would be a rigid material. But in many cases, you want like a soft interface at the end of the end of arm tooling to grasp things kind of more gently. That's another area where we see a lot of potential. And then life sciences, there's a lot of, especially with these chemically resistant materials, there's a lot of interest for a lot of lab hardware and fluidic hardware for handling different kinds of fluids as well.
So going back to the multi-material aspect, does it get any more challenging with the vision systems? Like I could imagine as you're looking at a build, you have uncured and cured. I mean, like that's one state, right? But then you have material A and material B next to each other, and that's another state. Does it get is that a challenge that you guys see in doing some of the vision systems, or does that not even matter? Am I thinking about it the completely wrong way?
Yeah, the vision system sees the materials and tries to correct in real time, and we actually are now in the tail end of developing a material identification as well on the build. So not only can we scan the geometry, but also identify what material is in any given voxel. Multi-material is also a challenge on the chemistry side. So you need to make sure that, for example, you're printing rigid and soft materials, that the two adhere together well and place nicely with each other. So there's definitely some challenges on multi-material processing, on the in-process inspection, and then the correcting algorithm adds like another layer of complexity as well, like you were suggesting.
Do you have all these different kind of problems that you're solving along the way? There's materials issues, there's computer, memory, vision, kind of coding issues, there's the mechanics of the machine. How do you go about building a startup team to work on that and start to solve those problems?
Yeah, that's a great question. We always tell people that that 3D printing companies is starting three companies. You're starting a hardware company, you're starting a materials company, and you're starting a software company. So yeah, the team is the foundation of the company. So we have this little three companies that we want to build, and we're lucky to be in the Boston area where there's a lot of talent and other 3D printing companies as well. So there's a really nice ecosystem of people passionate about 3D printing, great engineers, and we're also, like I suggested before, we're part of this MIT ecosystem. So there's a lot of great talent in the area. But I mean, to build a great team is the first thing is always to start with a challenging, attractive problem, and once you have that, it's easy to motivate and inspire people and really get the whole team kind of pulling towards this vision.
And can you kind of give a little bit of kind of highlights of kind of what's on the roadmap? Kind of what are you guys kind of looking to do in the coming months and years ahead with the technology as you're developing? And are there kind of big goals in mind that you're looking to produce certain products or go into certain verticals? Yeah,
so I would say up to early this year, we've been in kind of R&D mode. And so now we're a state of the company where we're transitioning into a more commercial and public phase. So the biggest milestone for us is releasing our first product, our first system that will be installed in our first customers. So that's I'd say the kind of number one product milestone that as a company we're releasing our first product. We're working with a variety of customers across these verticals that I mentioned, and we have a lot of projects in the pipeline that we want to get to the finish line in terms of taking the designs and concepts and actually having these products be manufactured and produced with 3D printing. And that's one of the key aspects of our vision. Like many other people, we're trying to take 3D printing to production. So moving from this prototyping legacy technology to how can we make end products with 3D printing. And there's been a lot in metal and plastics as well, but definitely the potential hasn't been even scratched, I think. So I'd say on the product side, we have our machine that's being released, and then a few of our customer projects that will go full commercial next year.
It's always an interesting time in kind of this stage of the growth of a 3D printing company, right? Where we've seen it in many other companies that kind of have gone through your kind of path where you've been, where you've got the machine, kind of you're trying to sell more machines. You also have customer projects where you're doing a lot of kind of mix of R&D, maybe materials, maybe modifying the machine a little bit, all as you kind of feel your way into kind of what markets are going to stick, where the big kind of drivers are going to be. And so probably where you're sitting is like every day is about prioritization and like, okay, is this going to make sense? Like, how do you scale it and things? So it's both, I imagine, fun and sometimes stressful kind of day-to-day job.
Yeah, and I'd say that a lot of people are starting to become way more aware about 3D printing in the past, I'd say 3 to 5 years. So people are very curious and excited about trying to understand what, as a company, they could do with 3D printing. So there's many different levels of expertise across companies. So some people are experts and they come with requests that really fit the technology, and some people come with things that kind of are more in the dreaming bucket. So having a pipeline and a team that's clear, what can we do that no one else can do, and prioritizing, like you said, Mike, all the different requests it's like juggling. Every day you're juggling all these different opportunities, and being strategic and careful about which one you choose can make or break the company.
A lot of the people that listen to this podcast are either kind of somewhat new to the industry or thinking about kind of exploring 3D printing as a career, as a transition from another place in manufacturing or engineering. What advice do you give them as they explore that journey or start that into kind of looking at potential jobs and roles? Like, what is there any piece of advice that you'd give them?
Yeah, I'd say, well, first of all, I love manufacturing. I love things being made, touching things, the complexities of it, both technical and, economic, commercial. It's kind of a really interesting field and place to be. It's really exciting to feel the energy of things being made and machines running. My advice is always to be curious, to always try to be on the cutting edge, be curious about what's out there, the new technologies. And sometimes things feel grim in the country, around the world, but in average we're moving ahead, and there's a lot of exciting things that are happening in the world of manufacturing, especially 3D printing. I mean, it's amazing how fast the industry is growing, and the growth that's projected over the next 5 to 10 years. And so there's definitely a lot of opportunities to develop new technologies, solutions, organizations built around 3D printing. So there's a lot of exciting white space, I'd say, to build some pretty amazing companies and careers, for everyone that's looking to get into the manufacturing industry.
Absolutely. And so are there any other things you're looking forward to in 2021? Either kind of showcasing your technology more, or just personally, professionally, as a company? What else is on your radar?
Yeah, well, I hope as a country we get vaccinated and we get to the end of COVID. But as a company, we're projecting a boom on our technology. So we're going to release a product tomorrow, February 23rd. So the main milestone for us is really transitioning to this more public commercial entity. So we're looking forward to new exciting projects with customers and partnerships. That's really what drives us as a company. And then in 22, deploying our first machines to our first customers. But really, we're trying to drive towards that goal of installing those first machines, first customers.
Fantastic. Well, Javier, thank you so much for joining the show today, and wish you luck with everything, and hopefully see you around the manufacturing floor in person soon.
Thank you, Mike. Really appreciate the opportunity to talk to you.
Thank you very much.